Okay, now let's go ahead and take a moment to look at problems that have different denominators. So we're going to do quite a few examples here. So when we were talking about the 1/2 and the 1/3, right? And we found a common denominator by multiplying, and that common denominator we found was 6. And what we call 6 is the lowest common multiple or lowest common denominator of 2 and 3. Okay, 6s. What's the lowest common denominator that you could use for 7 and 2? What number does 7 and 2 both go into? 14. And you did that by multiplying 7 and 2 because 7 times 2, they're both prime numbers. So here we're multiplying by 7 over 7. That's one whole. Here we're multiplying by what? 2 over 2. So the equivalent fractions are going to be 6/14 plus what? And how many 14ths is that then? Now we have a common denominator. We can add the numerators and we get 41/14. Is that what you said? Can we reduce 41/14? Probably not, because I imagine that 41 is a prime number. We could test it out and see, but I'm pretty sure if you tried to factor 41, you could say, well, it's not divisible by 2. It's not divisible by 3 because 4 plus 1 is 5. You know that about the divisibility rule for 3 if you add the digits? And it's, so like for instance, 4 plus 1 is 5. 3 doesn't go into 5, so you can chuck 3. It doesn't divide by 5. It doesn't divide by, we could test 7, but I know my 7 times table, so it's not going to be divisible by 7. So 41, we're pretty safe to bet that it is probably prime, so we can't reduce this. You could write it as a mixed number. How many 14s would fit into 41 if we divide? Anyone know? 2. So we would divide 4 and what? 13/14. Because maybe 14 times 3 is 42. Is that right? 14 times 3? 14 times 3 is, 42. So 13/14 is one. It's one number shy of dividing in evenly. Okay, great. All right, here, do we have a common denominator? No. And this is where it gets a little bit tricky, okay? Because we have an x involved. So just like 1/2 and 1/3, your denominator could be 6, but then you also are multiplying by x. So you have 2 times 3 times x. That's actually your lowest common denominator, LCD equals 2 times 3 times x, because I have to have a 2, I have to have a 3, and I also have to have an x. So our step 1 is going to be able to find the LCD. Okay, and then step 2, what should we do after we find the LCD? LCD is 6x. We're going to make what? Make equivalent. What am I going to say next? Fractions. Good. Okay, so what do I have to multiply this in order to get my 6x in the denominator? 3 over 3, right? Because we're multiplying by one whole, so I get 12 over 6x. What do I have to multiply this one by? 2 over 2, and I get 18 over 6x. Now do I have a common denominator to add? And so when I add them together, what do I get? 30 over 6x. Will that reduce? Yes, 5 over x is reduced. So we made equivalent fractions, we added numerators, and then 4 we reduced. Okay, any questions about how we got that? All right, let's go on to the next one. So C is telling us we want to subtract these two things, right? But we don't have a common denominator. Now, one thing we can do when we're finding our LCD, the LCD is going to be, we want to factor the denominators. So this is 3x minus 9. What would it be if I factored it? 3x minus 3. So you can see that here I have a 3 or an x minus 3. What do I need in order for this? Because that right there is factored. We're only missing the 3. So what should I multiply this one by? 3 over 3. Good. 3 over 3, I get 6 over 3 times x minus 3. I could distribute that, but I don't need to. I could keep it in factored form. Minus 11 over 3x minus 3. See how I have those common denominators there? Because of factoring, anytime you can factor, you should just factor. Period, right? So now what? What would I do next? Subtract, yeah. Yeah, subtract straight across. Subtract the numerators. And so we have negative 5 over 3 times x minus 3. Okay? If 5 were not 5, let's say it was negative 6, for example. So like, for example, just on reducing, we can't reduce here. But let's say, for example, it was negative 6 over 3 times x minus 3. Could you reduce that? What would it reduce down to? Yeah. This one can't reduce. This one, I just wanted to change the number just so that you could see how that would work if you did want, if it was possible to reduce. So it looks like what we did is we found the LCD by factoring. We made our equivalent fractions, right? And we subtracted the numerator. So similar steps to what we wrote out for the last problem. Okay, and then I'll just make myself a little space over here. So the very first thing we're going to want to do for this problem, I'm just going to draw a line here, okay, is we want to factor x squared minus 81. What does that factor to? Yeah, x minus 9, x plus 9. And then we want to factor the second one, the second denominator, 2x plus 18. What would that factor to? 2x. I'm just factoring out the GCF, which is 2. I knew what you were saying. I knew what you meant. Okay. So what is the LCD? The first step is to find the LCD. We had to factor in order to find the LCD. The LCD has to include everything, right? So it has to include an x plus 9. That's what they have in common. Has to include the extra 2, and it has to include the extra x minus 9. So the LCD, does anybody want to take a guess at what they think the LCD would be? 2x plus 9, x minus 9. So they have one x minus 9 in common. We call that the GCF, or I'm sorry, x plus 9 is in common. The x minus 9 is the extra, and the 2 is the extra. So the LCD has to include both denominators, all of both. So what would I need, if I'm going to write this out, okay, I'm going to just do a little space here. 27 x plus 9, x minus 9. What is this one missing from the LCD that it needs? It needs to be multiplied by 2 over 2. So we would multiply this one by 2 over 2, and that would give me what? 54, 2, x plus 9, x minus 9. Now I'm going to add that to 3 over 2 times x plus 9. What is that one missing from the LCD that I need to multiply it by? Just the x minus 9. So we have x minus 9 in the numerator, x minus 9 in the denominator that I'm going to multiply it by. So I have And I could distribute this. 3x minus 27 over 2x plus 9, x minus 9. You see how right here, I just distributed this? That's because I'm going to add those numerators together, right? Now that I have a common denominator, what can I do to the numerators? Combine them. Combine like terms. Good. So here we have 54 minus 27. Well, since I know that I doubled 27 to get 54, if I subtract 27, I must have 27 left. So I have 3x plus 27 over 2 times x plus 9, x minus 9. Okay, can I simplify? Factor. So when we want to simplify, we need to factor the numerator, right? So I want to be able to simplify. And to do that, I'm going to factor. So I get 3 comes out. If you factor 3 out, what's left? X plus 9 over 2, x plus 9, x minus 9. Can anything reduce? The x plus 9 gets canceled. So our final answer is, and I normally would write it vertically, but I'm running out of space. So I have 3 over 2 times x minus 9. And what should x not include? Negative 9, because that's what was canceled. We can see that x should also not be 9, but I don't have to include that because it's basically what we consider obvious. Just by looking at the denominator, I know I can't use x equals 9. So I don't have to say it because I only have to say the one I canceled out, right, as my restriction. Any questions on that?